CCS Catalog Breakdown Part 2, Line Scan Lights. We are going to structure this the same way we structured the first catalog breakdown. First, we're going to talk about the product pages. We're going to go through what the important information is that's given and how to interpret that information. Then we're going to talk about the product types, what series goes with each type, and what our go-to is in each one of those. And then we're going to go through how to choose the right products based on the information the catalog gives you to make sure you're having the right light for your application. Before we start with all that though, I want to talk about line scan versus area scan systems. An area scan system is where the camera captures the entire field of view in one frame. There's a lot of pros to area scan, the main one being that the sample can either be stationary or it can be moving, so you have that flexibility. The cons, however, is that you are limited in the resolution of your camera. So if you have a setup and you just need a little bit more resolution to your image, unless you get a new camera, there's not much you can do other than increasing or decreasing the field of view and increasing your resolving power in your image. But if that's not enough, then you have to purchase a whole new camera. So you're kind of limited in that regard. When it comes to lighting techniques of area scan camera, it's all of the techniques we've talked about in our training videos, our webinars, our on-site training. You have your bright field images, your dark field, backlight, coaxial, collimation, dome light, polarization. They all come into play when you have an area scan system. When it comes to line scan, the difference is that the camera is capturing one line at a time in one frame instead of the whole field of view. So you make up your whole field of view by how many frames the camera takes, and then the software merges them together into one final image. A good way to think of it is a loaf of bread. Consider one frame is one slice of bread. When you put all the slices together, you get a whole loaf. That's your final image. The pros to line scan is the flexibility of the resolution. You only have it fixed in one direction, so let's say that your Y value is fixed with an 8K line scan camera, so you have 8,192 pixels in the Y direction. The X direction is dependent on how many frames you have, so if you need more resolution, you can just add more frames. So you have that flexibility there to get the quality image that you need with the line scan camera. The kind of downside to it is that the application has to be moving. If it's not moving and it's stationary, then your picture is just going to look like the one frame for your whole field of view and you're not going to have any important data. But if it's moving, then you can create one long flat image. So there are three kind of different application types when it comes to line scan setup. There's a continuous sheet, which would be something like inspecting paper or sheet metal going down a line, or plastic, line of plastic, something like that. Cylindrical samples, where if you're looking at like a bottle, you can take the bottle and rotate it 360 degrees while your line scan camera is imaging it, and then your image of the label, for example, will be just one flat image looking at the entire label with very little distortion. If you were going to take that same bottle and look at it with an area scan camera, you would have to have anywhere from 3 to 4 cameras looking all around the bottle, and then your image, the images you're going to get are going to be 4 separate images with a little bit distortion and curvature around the edges. You might not be able to see the whole label in one. Even with all 4 images, you might miss something. Or you could still rotate the bottle and take continuous pictures of the area scan camera, but you're still resulting in the same 4 or 5 separate images, and you could still miss something. The last continuous application that you can do with line scan, you can do samples on a conveyor. It works the same as you just trigger the camera and have it go for a certain number of frames, and then it stops, and then when a sample goes by, it's triggered again. So it is still possible to not do continuous applications with the line scan camera. When it comes to lighting techniques for line scan, it's a little bit different than area scan, because with area scan you had to have the whole field of view as a consideration. So your dome light had to be bigger than the field of view, maybe 2 times bigger. Your working distance was really important, and you had to have uniformity across a whole field of view. Versus for line scan, you are just trying to make an even image on one line of pixels. So you can do bright field and dark field and backlight, but it's not necessarily finding the right dome light. It's more about taking that line scan light, which is more like a bar light, and putting it at the proper angle and the proper distance away from the camera. So it's a lot easier in some ways to get the right lighting in line scan, because it's just how convergent or how diffuse is your light, or how uniform is it, and at what position do you put it. You can also do backlights with line scan cameras. Coaxial and dome are applications that aren't necessarily common, but if that's how you have to solve it, it's important to have that type of light. I listed polarization because it can be done on a line scan system, but it's not as critical as it is an area scan, so I want it listed here just so you know that it is an option, but it's not particularly common. So getting into the product pages and looking at the important information. So looking at the LNSP2 as our example that we'll step through, the first information to look at is the illuminance graph that will be provided. The difference between the line scan illuminance graph and the area scan is the relative illuminance. With an area scan lights, most of this information was listed as a percentage, meaning the light was brightest at this working distance and dimmest at this working distance, but we didn't necessarily know what the lux value is. With line scan lights, we do provide the lux value. So you can see here that the LNSP2 is about 900,000 lux at the shortest working distance. So that's kind of the difference between area scan, line scan when you look at the illuminance graph. The next thing that I don't necessarily highlight, but I do want to talk about is if there's any comparison information between an old light or a new light or two different kinds, that's going to be listed here as well. So in this example, it's the difference between the NDF type and the standard type. NDF means no diffusion. So that will be listed here as well. Next, it will put an example configuration. So you can see here it puts the line scan light at the edge and then the camera looking straight down. As I said before, the light and line scan systems, the angle and the working distance is what's most important. So this is not the only configuration that you can do with this light. This is just one example of how it can be set up. You can have the camera at an angle and the light at an angle. You could have it more straight down. You could have it more from the side for low angle. There's lots of different options you can do. So this is not the only way. This is just an example. Next is looking at the irradiance data and the uniformity. So what this is telling us is the uniformity of the light. So I like to look at this graph here because it tells you this is a 300 millimeter light. So this is looking at 300 millimeters here. It's looking at the data. So you can see the uniformity of the light is not great for the first 25 millimeters on either side. So if you want a very good uniform light on your field of view, for a 300 millimeter light, your field of view should be about 250 millimeters. Give yourself about 25 millimeters on each side to get uniformity so you don't have dim edges. So that's what this graph will do. The relative radiance distribution graph will tell you what the uniformity of the light is. And you can see it here with the NDF version. There's a lot of waves because there's no diffuser, so you're looking at the intensity of every LED. So that's how you can tell the difference between those two lights. Then you get to the product lineup. It tells you, all the products we have. The ones in red mean that they can be done, but they're a little bit more custom. All of the power consumption data, what extension cables are used, the recommended controller units. This is always an important one to pay attention to because a lot of times the connector type from the line scan light is important, so it can only be one controller for that certain light, or the size will be the limiting factor, and then the weight of the unit as well. Then we talk about the extension cables and options. So not every light will have options, which is why I don't have it highlighted, but certain ones do, so if it does, it'll be listed here. When it comes to the extension cables, it is important to pay attention to this. When you have area scan extension cables, for the most part, it's an SM connector or an M12 connector if it's ordered that way. Flying lead also if it's ordered that way. Some of them are EL2 connectors for kind of the more powerful lights. For line scan, they're going to be EL2s or some metal connectors that are kind of different, less common connector styles. So it's more important to make sure that you have the right extension cable used and ordered, so you don't have to reorder the extension cable if you accidentally ordered the wrong one. So pay attention here, and that's also listed on the lineup information as well. Then you get to the dimensions. With line scan, the dimensions are a lot easier because you don't have to put the dimensions of each light. If we did, that would be a lot of information because we'd have up to, a lot of products. But the way that the dimensions work for here is it gives you dimension A and dimension B. And so A is the emitting surface and B is the full length. So if you look at the LNSP2 300, the emitting surface is 300 millimeters, but the full length of it is 325 millimeters. And then it tells you the connector, and this is kind of the standard. This is a little bit longer lights. The rest of it is going to be consistent. So the width and everything like that, the connector type, all of that, that's consistent. So we just pay attention to the emitting surface and the overall length. That's the difference that changes. So all of the dimensions for all of the lights are just in this one page here. So that's pretty much the breakdown of what the product pages give you. Some of them have a little bit different information, but it's all going to be relatively consistent in what I went through. Now that we've figured out kind of what's important with each product page, we're going to talk about the different product types that we have. So there is convergent lights, diffuse lights, and oblique angled lights. Convergent lights are meant for bright field lights. So they're where the light is directed down to be very in a thin line and extremely intense. They usually have certain working distances, they're highly directional, and they're really good at bringing out contrast. So our standard convergent lights, which are meant for direct above lighting, not backlighting essentially, we have the LNSP2, the LN and the LNHK, and the FE line 3. So the FE line 3 has an asterisk here, and that is because it's not talked about in the catalog in this portion that I'm talking about, so I'm not really going to go through it more in depth, but it is a good standard line light, so I do want it known that this is a good option to look at as well. The difference between the LNSP2 and the FE line 3 is going to be size. FE line 3 is a little bit bigger, the LNSP2 is more compact. They have a similar intensity and a similar uniformity, and then cost, FE line 3 is a little bit lower cost than the LNSP2. So decide, what you're prioritizing in your project to decide between those two. When it comes to high intensity line lights, that's going to be what we consider 1 million lux or higher. Our products are the LNLP, the LNSPFN, and the LNGA and LNHA. Those two also have an asterisk for similar reasons. They're not in this portion of the catalog, but they are bright line scan lights that we sell with iTech. So they're just another thing to consider if you're looking at really high light. I'll talk about them a little bit more in the next page or two. And then we have flood line lights. So these are just essentially the same as standards, but they can just be made really long for a little bit lower cost. So the products that we have for these is actually taking an FE Lux bar light and converting it to a line scan configuration. So you can take the FE Flex and put the lens position at the most narrow at 10 degrees and put a line scan film. And what that line scan film does is it diffuses the lights, but only in one direction. So it kind of makes a flat sheet of line light. It's not extremely convergent and extremely intense, especially compared to more dedicated line scan lights, but it is really low cost for a longer length. The other option you can do is FE Flex CYLs. That's a cylindrical lens. So that's where on top of the line scan film, you put the lens position at position 1 and you add this cylindrical lens to it, which really converges the light into a really thin line and it adds intensity to it. So those are the two ideal flood line lights that you can do. The FE line 3 can also work as a flood line light, but it's going to be more expensive than just converting the FE Lux bar lights. So our standard convergent lights, our go-to is going to be the LNSP2. The reason for this is it's very high luminance, it's very compact, it can work as a front light in bright field or dark field, again just depending on the angle at which you're putting it to the camera. This example configuration has it set up as a dark field illumination. The applications for the LNSP2 are just kind of standard line scan applications that use front lighting, so you can look at stains and scratches. Any visual inspection on circuit boards is a common one. Woven, non-woven fabrics, stuff like that. So there's the difference that I've mentioned the LNSP2 and the LNSP2 NDF, and here's kind of the difference between them. The LNSP2 NDF has more intensity, but it does not have the uniformity. So you can see here looking at a metal sheet with standard type, you have much more uniformity, but looking at a really reflective metal sheet with the NDF type, you can just see exactly where those LEDs are and where the LEDs aren't, and they're not uniformity. So the difference between choosing these two is going to depend on your sample. If your sample is extremely diffuse, then you can get away with using the NDF type because it's going to diffuse the light and it's going to be uniform in its own way. If your sample is more reflective and you use the NDF type, you're not going to have a uniform image, and that's where we need to use a standard type that has the uniformity. Another option that the LNSP2 has, which is another reason it's our go-to, is it has a coaxial unit that attaches to it. So this just is a half mirror that's angled this way, and then the line scan light slides here, shines into the half mirror, is reflected down, and then back up into the camera. You can see how it's set up here. And the point of having a line scan unit on your light is that you can have light going directly down onto the sample and not at a slight angle. And you can get into inspect between two tall structures that are really close together. Or you can use it for collimation properties, like we use a line scan light in area scan situations. When it comes to our high intensity lights, our go-to is going to be the LNLP, which has 1,000,000 lux and it doesn't have any cooling fans. And it's the same setup really as the LNSP2. The only difference is it just has a lot more intensity. That could either be if you're using a really fast exposure time or line speed, you want more intensity so you can keep up with that line speed, or if your light is going to be placed a lot further away from the sample. To make sure you have enough light hitting the sample and going back up into the camera, your light has to be pretty bright. So that's kind of when you're getting at those high intensity lights, those are the two situations. The older versions is LNSP FN, so that's with the LNSP, old technology with a fan attachment. So that makes it where we can have the LEDs at a higher intensity because we're cooling them with the fan. But you can see this is from the catalog. This is a comparison between the LNLP and the LNSP FN. The LNLP is brighter and it doesn't have a fan, so that's what we recommend as opposed to this older technology. The iTech lights, which is the LNHA and the LNGA, these are going to be 2.8 million lux or 1.2 million lux. In terms of the difference between, the LNLP, the LNHA, it's just how intense your light needs to be. If the LNLP isn't quite bright enough, do the GA. If that's not quite bright enough, then upgrade to the HA. But otherwise, they all have the same uniformity purposes. How they set up in relation to the camera is all going to be the same. So that is actually our two go-tos for the convergent light. I'm not going to talk about floodlight because it's Effilux products and that's not a part of this portion of the catalog. So now when we move on to the diffused light, this is used as a backlight. So this is meant to be extremely uniform and extremely diffuse. So when you have the backlight shining directly into the camera, if there is any type of not uniformity, it's going to be a lot more obvious when you're not reflecting off a sample and kind of diffusing the light. It's just going straight into the camera. So you'll be able to tell if there's a bright spot on the light. So these lights are specifically manufactured to be uniform and to provide very even illumination for a consistent backlit image. So our standard is going to be the LNSD, the LND2, the LT, and the TH2. The dome line lights are going to be they're going to provide the shadowless light. There's LFXV, the LNEAA, LNEBA, and the LNV. And then the flood line lights are just kind of long backlights. And these are going to be the Effiflex BL. So this is not the Effiflex light with an attachment on it. It's the Effiflex BL is the part number, and then you add, the length and stuff like that. And what that light is compared to the Effiflex is it has twice the number of LEDs, and then the diffuser that they use is our most diffuse diffuser. So this is not quite, you're still taking a bar light and converting it to a line light, but this light is made to do that, but it's still not like the FE Line 3, which is a line scan light. So it's a diffuse backlight, going to be much more cost efficient for those longer floodlights that you need, especially. When it comes to the standard backlights, our go-to is the LNSD. And this is a very highly uniform, diffuse line light, but it's also got a very small profile. And this is going to be your standard, used for your standard backlight line scan application. So you can see for scratches, holes, edge breaking on paper, if you're looking at gloss or unevenness, dense and formed materials, holes in clear film, stuff like that. There are two types of the LNSD. There's the standard one and the LNSD HU. So the HU you can see has a wider emitting angle, and that means high uniformity. So essentially, because the LEDs emit at a wider angle, they are more uniform, but they are less intense. But when you're using it as a backlight, usually intensity is not the problem because the LEDs are shining straight into the light. So if you have a sample where you need just a very uniform, if you're looking maybe at clear glass, something like that, the high uniformity would work. Or if you test the LNSD and it's just not quite uniform enough, then you can step up to the LNSD HU. The other option that we have is the TH2, and that's because it comes in the size, the 300 by 75 millimeters, so it can work as a backlit application, but that is the biggest that it goes. So if your field of view is more than 250 millimeters or 300 millimeters, then you can't use the TH2, you'll have to use the LNSD. But the kind of applications here, same as the backlight, looking at stains, cylindrical containers, stuff like that. It's just providing a good diffuse illumination. Other versions that we don't use, they're kind of earlier technology, is the LND2 and the LT light. They're in the catalog because we still sell them to some people, but we don't recommend them moving forward anymore. When it comes to dome lights, our go-to is going to be the LFX-V, but that's also limited in the size. They're made at 200 by 100 millimeters or 300 by 100 millimeters. So again, if the application is longer than 250, 300 millimeters, this LFX-V light's not going to work, but it is a great shadowless light if your field of view is smaller at providing, getting rid of those 3D height changes, looking at metal inspections, PCB boards, something like that. The earlier version is the LNV, which is actually a coaxial unit. So we don't recommend it, A, because we have the CU LNSP2, and it just isn't really used anymore. The iTech lights are the LNEBA and the LNEAA. So these lights are designed more like this, where they are actually a dome light that has a line that the camera looks through across the whole thing. The difference between the EBA and the EAA is the emitting surface. So the EBA is 100 millimeters and the EAA is only 50 millimeters wide. When trying to decide between these two, testing is going to be your best bet. I would say the more reflective that your sample is, the wider you're going to want. But always test if you can. Maybe start with the bigger one, and then you can kind of cover up the bottom of it to make it more like an emitting surface of 50 millimeters and see if that still solves your image. If it does, then decide between the two. If it doesn't, then you have to have the wider one. So that's how I would recommend testing between those two. Next, we have the oblique angled lights. These lights are going to be unique to CCS. We invented them, and we're the only ones who sell them. And the point of these lights is to detect the scratches that are in the same direction as the moving web. So they're angled illumination, so they're kind of essentially a line light coming from the side of the web as the direction's moving. So we have the single angled lights and the bidirectional angled lights. For the single angled, we have the LNDG. Bidirectional, we have the LNIS, LNIS2, and LNIS-FN. So here's maybe a better example of showing what the LNDG does. You have it offset slightly to your camera so that light is being reflected at an angle, so it gives you those height changes of the wrinkles that are in line with the moving direction of your web. So with the standard light, you wouldn't be able to see it, but with the LNDG coming from the side, you can detect those much easier. So anything that's vertical, wrinkles, striations, unbonded sheets, cardboard, fabric, that's where this light's really gonna shine, pun intended. When you have the bidirectional angled light, that is essentially taking the light and having it come from both sides. So it's essentially if you were to take two of the LNDGs and place them opposite each other and combine them into one, you get the LNIS2. So this works great for streak inspections of sheet surfaces, clear films, glass, similar technology, but just kind of coming from both directions. And then it's in line with the moving direction of your camera. The way this one is set up is it's more in line with the camera instead of off to the side like the LNDG was. The difference between the LNIS-FN and the LNIS, the FN is fan equipped, so it can get much more intense because we're not really worried about the LEDs overheating due to the fan. The LNIS and the LNIS-FN are kind of older technology, so we do typically go with the LNIS2 as our recommendation. So that's actually it when it comes to line scan lights. Because they are very just bar lights essentially with your one line of your camera that you're inspecting, there's not that much that you can really do with it besides changing the uniformity or coaxial dome, that kind of stuff. But it's not like area scan where you can have square, big, small, lots of different options with the area scan that you have to consider. So there's not as many line scan lights as there are area scan lights, and we can still solve most or all of the applications. So now that we know the lights that we recommend, how do we take a sample that we have or an application that we have and choose the right product from there? So in the catalog, right before you get to the line scan section, there is this little light line list index. And what that does is it shows all of the lights as just a little bit of a summary of each one. So it shows if it's convergent or diffused. It lists what their intensity is. It shows the uniformity of the light. and then a picture of what the light looks like so you can kind of get an idea of if it's going to fit in your space or not. So this is just a good tool to kind of look at and say, okay, I know I need a uniform light, so that knocks out this one. I know it has to be convergent, so I just look at these, and then you can kind of narrow it down from there. So it's just a good tool to start with to get your a good idea of what series to focus on. So we have our series go-tos. This is essentially summarizing what I just went through. If you need a backlight for your application, our typical go-tos are going to be the LNSD and the FE Flex BL. The difference between choosing of these two is going to be the length. If it's a really long light, then maybe the FE Flex BL is your best option. One caveat to shipping really long lights is it gets expensive quickly once your light gets above a certain size. So what we recommend typically is if your light is above, if your light is really long, we say you should actually buy 2 lights that are half the size and then ship those 2 lights. It'll save on, boxing up the light, sending it, just putting it on. However, it gets over here. If the light's really long, that gets really expensive and hard to do. So as much as we can make lights that are, 3 meters long, they're usually so hard to ship and so expensive to ship, it's not really worth it. We would recommend doing, 3 100 millimeters or even 4 600 millimeters, something like that. But otherwise, the LNSD is going to be a smaller profile, so if you don't have a lot of space, that's going to be better than the FE Flex BL. But they're both really good diffuse backlights. I would say the LNSD might be a little bit more uniform than the FE Flex BL, but that's kind of the difference there. If you're looking for a front light and then you want to do a dark field illumination, which is you need a high luminance and a really focused light to make sure you're getting enough light to reflect off, the etched whatever, scratch or whatever to meet your camera. The best convergent light is going to be the LNSP2 or the FE Line 3. These are our go-tos. The difference between these two is size is number 1. LNSP2 is more compact than the FE Line 3. FE Line 3 is going to be a little bit more cost effective than the LNSP2. So whatever you want to prioritize in your application was kind of be how you pick between these two. If you need dark field oblique lines, we're trying to see those scratches or dents in the vertical direction, then you need the LNDG or the LNIS2. Unfortunately, I don't have a good pick this light for this situation and this light for this situation because they are so similar to each other that we just recommend testing both of them if you're having that problem come up in your sample. Try and test both of them on your system to see which one works better for your application. If you are looking at a bright field illumination, so also requires high luminance and have high directionality, then you, again, because line scan is it just matters where you put the light in relation to the camera and how far it is from how far the working distance is. We still recommend the LNSP2 and the FE Line 3. If you need a coaxial unit, our go-to is LNSP2 plus the coaxial attachment. And then if you need a dome light, if your sample is longer than 300 millimeters, then we recommend the LNEAA or the LNEBA. And most line scan applications are. So that's kind of going to be our go-to in this scenario since it's what most of the applications will require. When it comes to picking the size, we actually have a calculation in the technical guide of our catalog. And so it tells you how to figure out the emitting surface based off the field of view, the working distance, and the light working distance. So you can use this to get an idea of what size light to order. But we always say test, test, test. So maybe try it first and then pull the trigger, but it's a good way to start to figure out what size light you need. The things that would make it not as accurate is the reflectiveness of your sample. If you have a really diffuse sample, you could maybe get away with a smaller light. If you have a really reflective sample, just to be safe, you may want to order it a little bit larger. There's also the W rule, which kind of coincides with this. Essentially what the W rule is, to have perfect uniformity at the far edge of your extremely reflective sample, you have to have light coming from the angle of incidence that it reaches the camera. And that ends up making the light have to be about 2 times the size of the field of view. That can get very big very quickly, and that really is just the case for extremely reflective surfaces like mirror-like. So as your sample is more diffuse than that, or your light working distance is a little bit closer, you don't necessarily have to be 2 times the field of view. You can be 1.5, maybe 1.25. Testing can determine that, but it's just a good idea of, thinking about how big does my light have to be. Think about how reflective your sample is, what your working distance is, stuff like that. When it comes to wavelength, I didn't mention this before, but most line lights as a standard come in white and maybe red. And that's typically tends to be that line scan applications, the color isn't as important. That being said, in some applications it is very important, so most of our lights can be made a certain color as a made-to-order type of light. So if you do need a blue line scan light, even if it's not listed in our catalog, please reach out to your salesperson. It can pretty easily be made for you. And then when you're looking at colors of lights, like colors lighten and opposite colors darken. So if you have a red sample that you want to make it appear bright, you would use a red light, because that's going to lighten all of the light. It's going to reflect off a lot of light into your sample. If you were to use a blue light, you were going to darken that red, because it's going to just absorb all the blue and not any light is going to reflect off and go to the camera. So that's kind of the difference between what color to use and when to use it. If you have products that vary in color a lot and they're not consistent, then we usually recommend going with white, so you don't have, maybe it works for one sample, but then the blue light works for one sample, but it's terrible for the other sample. White's going to be a little bit more consistent between the two. If you do use IR light, it does remove all the colors. And then we always just say test the wavelength before you're doing your final purchase, because you don't want to purchase a blue light because it worked for 1 or 2 of your samples and then have your 3rd or 4th go through and it's awful for those 2. So test on all your samples before making a purchase. So that is our webinar. I hope that this was useful for you. If you have any questions, we will stick around in the chat. Otherwise, thank you so much.